Hey everyone, welcome back to the lab. In this video, we're going to be talking about how to build type-safe server-side HTML renderers with F# and Giraffe, basically so you can do your server-side HTML rendering with all of the typing power of F#, which is one of the great reasons it's a great language. For the past several years, I've experimented with different tech stacks with the goal of making building apps more simple and fun. Cloud Seed is my best answer so far, an F# web API that can interface with the front-end technology of your choice. This allows most of the app to be built in my favorite language, F#, while allowing flexibility to use whatever tech you like for your own front end, because that's like a, very contentious subject. What's the best tool for front end? Just so you know what I'm talking about, Cloud Seed is my F# project boilerplate. It's basically mostly F# on the back end, integrates with ORM to whatever database you want, and then I have just a little default Svelte kit here because that's what I like to use, but pretty easy to remove and add your own front end. The problem is that all apps really need a front end. And yeah, this might seem like a overgeneralization, but it's not. Like every app that needs to interface with humans needs a front end. So if any app you're building doesn't ever interface with humans, it's probably not an app that should be built. So sounds contentious maybe to overgeneralize, but I think this is true. So by not supplying a rock solid default, users must bring or figure out their own. Cloud Seed currently defaults to SvelteKit, my current top choice for simple, flexible front ends. I like SvelteKit over React, but not everyone likes or knows SvelteKit, so they either have to integrate their own or learn a new framework. Even if they do like and know SvelteKit, like me, there's still the problem of context switching between the two tech stacks. And this is something I've struggled with a lot is like, one of the biggest things that we talk about gets in the way of deep work or like software engineering is like your constant context switching. So what you really want to do is you want to minimize that so you can like maintain your focus. But if you're two like apps or you have, multiple frameworks, multiple languages in your apps, then that's like hard context switch to go from language to language. But I found that this is like a pretty widespread issue. I don't know the answer yet, but something I think about a lot. Recently, I've been reading up on the hype around HTMX and have undergone somewhat of a brain blast exploring its possibility. It promises all the simplicity and power of server-side rendering with the reactivity of a client-side framework, a la Svelte, React, Vue, etc. This seems like it could solve my problem, allowing me to build 3S Simple Scalable System full stack apps with 90% of the code in F#, all while sacrificing little in the way of front-end power. And like, if you've used these other like language frameworks like Laravel, Ruby on Rails, Next.js, SvelteKit, like they're all doing this thing, right? Like they're all trying to simplify what you're doing into one stack, minimizing the lack or the amount of features you lose on each side, front end, back end. And I think this idea is good and probably more powerful than we've been able to extend it so far. And so this is like why I'm very excited about this. So in this post, we're going to explore the first part of this journey, server-side HTML rendering with F# Giraffe, with the next part being like, actually adding in this extra reactivity. But before we can get there, we got to get the HTML rendering working. All right, so how can we build type-safe server-side HTML rendering with F# and Giraffe? This is what we're trying to answer in this post. And so here's what I've got for you today. So in this post, we'll explore an example app built with F# and Giraffe. It renders a simple HTML table displaying a list of data from its database. This example will show you how to build type-safe HTML web components, simple performant HTML templating, and how to integrate all of this with Giraffe for routing. The app itself is F# and Giraffe for the app layer. For the UI, we've got HTML templates with Scribon, which we'll talk about later, served via Giraffe, which is just a popular F# web framework. For data, we're doing DBApp for migrations, Entity Framework for ORM, and Postgres for DB, though you largely don't have to care about this. And then I'm hosting all of this in Docker and Docker Compose for containerization and orchestration because I don't like running random CLI scripts. I like everything to be containerized. So in this post, we'll specifically be diving into the app and UI layers, including all the important source code here for you to copy and paste. The rest is just there to serve as a tracer bullet to prove this works in a full stack system. And so this means that like a lot of these layers are really just here for the example stuff. So we won't go into that because this would make this like an hour-long video. We don't want that. But if you want to learn more about this stack, you can read my post on getting started with F# and Entity Framework to understand about the data layer. And then for understanding more about like the web API itself and how it's configured and how you set it up with your .NET app, you can read this, which is build a simple F# web API with Giraffe. All these links will be. And finally, all the source code of this example app is available. So in this post, we're going to have the highlighted code sections so you can copy and paste it and do this yourself. And then if you want like the full source code of the whole example app that I'm showing here today, that's available to Minion subscribers in this little GitHub repo, which has a bunch of examples from all my past videos and articles and stuff. Now, before we go into the details of like how this is built, I wanted to first show you the working version of this. So let me come over here to my code. This is, as you can see, the example repo repo that I showed you. We're in the F# HTML templating one. And I've got my Docker containers running. So basically what they did is I ran it. It's running Docker Compose. It set up my little Postgres database in a container, and then it orchestrated to start the little F# app, and it's set up all of the tables it needs using dbup, and now it's listening with Giraffe. I'm not gonna stop this and restart it because today Docker registry is having problems, so it's a high likelihood this is gonna fail, but just trust me that, you know, I just ran this. This is the live code. Okay, so let's go back to our browser and hit this and kind of show you what it's doing. So let me reload so you know it's live. And you can see that every time I reload, we're seeing another list here. And this is what we're building, right? We want to build an HTML template. We want to be able to show that we can parse data from our .NET app, from F#. And so we've just got the simplest example that I could think of to show this. So we just have a page. It says it's a Sentinel table. This is a table internally. If I show you, yeah, it's just a very simple HTML table with the, you know, T-body, TRs, stuff like that. And then we're pulling off an ID field from the model we get back. And then this is actually a JSON field that we're reaching into and getting its field out as well. So every time we hit the endpoint, it's going to create a new one of these, what I'm calling a Sentinel. And then it's going to render all of this as HTML, this big table. It's going to construct it on the server side, and it's going to throw it back in one. Okay, so that's what we're building. Now let's dive into the different parts that you need. All right, first we're going to start off with HTML templates. So the first thing we want is an ability to do HTML templates, do HTML templating. Why do we want this? Well, we could just use raw string concatenation, and many people do. I know several people in the F# community do this, and it seems to work for them. In most cases, this is fine. But there are some edge cases where this could cause unexpected problems, like if you try to use special characters like the ampersand or the less than or greater than signs. These are all reserved characters by the HTML spec, so you need to first translate them into a different form, their entity name and number, if you want the browser to render them as the text you expect to show up on the page instead of trying to render it as HTML. So like, you know, this had to be escaped. Like this couldn't just be shown. And so if you're just doing string concatenation, it's very possible that you forget to do this and then your page is broken, and then you got to go debug why. So with raw string concatenation, you just need to remember to parse these special characters into their correct form. This is doable, but it seems like a pit of failure. The default is to forget to do this, so you need extra work to remember and not to fail. So for every string field that you're trying to use, like you pull it from the database, you're just gonna have to remember to do that. Now, by starting with everything as a template, it's clear we need to do the HTML parsing anyway, which takes care of this whole failure case for us. Thus, this is a pit of success that we're building. You can't forget. It's impossible to forget because we're just doing this every time. Plus, most templating languages give us some nice tools for conditionals, iterations, and value usages, so that's a plus as well. Okay, so picking an HTML template library. For this example app, I chose to go with Scribon, and this is a pretty cool library. Here's the GitHub, available on NuGet and stuff. API is pretty clean, you can see here. I like Scribon because it is, one, popular, so currently Scribon is the second most popular HTML templating library, though it also does a lot of other stuff. Behind Razor Engine, which if you're in C# world, you've like almost definitely used Razor in your career. And I really wanted to stay away from the magical code generation of Razor. Razor like is kind of one of those enterprisey feeling libraries where it's doing a lot of this code generation, kind of when you plug it into like your configure services and stuff like that. And for object-oriented programmers that is like using a lot of those kind of .NET internal core services, that's probably fine. But for an F# app, when we're trying to get rid of all of this like magical side effects, it's kind of like breaks the paradigm. So try to stay away from that. It's maintained. Latest updates are a few months ago. Always important for a library you're using. You don't want to get some abandonware. And it's pretty simple. So the API is nice and clean without any magical code gen steps. This means it should fit nicely in the FP-ish style of F#. Also, its templating language is very simple and similar to that of Svelte, Handlebars, or Liquid, so it's easy to onboard to. Yep, and I'll show some examples of this a little later. The next one is it's pretty fast. So the repo claims it's fast, and I ran my own benchmarks with regular size templates rendering in less than 1 millisecond. So you can read about that here. But yeah, things are running in less than 1 millisecond. I was a little bit worried about this because I don't really know what magic these client-side frameworks are doing to like render things so fast. And I was worried, especially like using Razor Engine in the past, that this was going to be some like really heavy compilation step, really heavy rendering step. And so I'd have to do a lot of like caching and stuff to make it fast. But actually found that these things are like pretty good at this kind of concatenation and data parsing and stuff. So it's not really a problem. So you can install the package via NuGet, which is .NET's package manager, via the Scribon NuGet here. Then and this is the command. So once installed, we can utilize Screebon to parse our HTML templates and fill it with type-safe data models with a helper function like this. So here's our helper function. We're saying, hey, give us a generic type, a T type, and then give us the template string that you want us to parse. And what we're going to do is we're going to use Screebon right here to parse the template, and this compiles it into some form that Screebon knows how to use. That's kind of internal implementation detail. We don't know how that works. And then what we're going to do is we're first just going to check, like, hey, does this thing have errors? If it does have errors, then, you know, something's wrong with our template. So we're just going to throw here because we don't want to recover really. Otherwise, we're doing nothing. And then what we're going to do is we're going to turn this function, which lets whoever called this function now have an access to give us the props that we expect this template to take. And it's just going to render it. It's going to say, hey, render the compiled template we have with the props we have. And then we're just doing this to configure Screebon so that whatever the property is on the object that you gave us, that's what it expects in the template. And I think this just makes it cleaner than its defaults. Okay, so that's how we get Screebon and how we get the library that we can use. Next, let's look how to build our type-safe HTML components with this in F#. So now that we have a way to parse and render our HTML strings, let's look at how we can build a page with components, similar to how you might split up rendering concerns in a client-side framework. So I'm a really big fan of like splitting these kind of concerns up. And I really think that's one of the big things that these client-side frameworks gave us, like React and SvelteKit and Vue and stuff. They allowed you to think of UI as in components in the same way that you would split up maybe your application logic into components and services and functions and stuff like that. So that's something that, like, if it's not possible to do for UI and server-side rendering, then it's probably not going to be more ergonomic and it's not going to be better. So we need to make sure that this. So we're basically trying to build a simple table that just pulls in data from our database and renders it. For this example, the data is just a giant list of sentinels. This is what I'm calling this model of like ID and data, a model that has a few strings in it. And so this is the example we saw earlier, just in the screenshot. So to render this, we're going to build, you know, a base HTML layout, which is like your parent page thing. And then we're going to have child components, which will actually do the rendering of the sentinel table. So let's start with the sentinel table. We can build this pretty simply by creating a new function, render sentinel table component, that takes in our sentinel list and returns the HTML string. While the string itself isn't very type safe, the input props are, utilizing the full power of the F# type. And so whenever we're like, you know, translating between layers, there's always going to be this kind of like unsafe danger if you don't have types on both sides, and HTML doesn't really do that, where you have to kind of wrangle the room for error. And so we are returning this, you know, HTML string that we create as a raw string, but we can kind of constrain our room for error here by wrapping it in this function that is type safe with all the power of F#. So we know that, you know, at least at this point of all the call stack above us that's calling this, we know everything must be typed in the way it is. And if the string that comes back is only dealing with the types that we know are true, here we've really narrowed down our room for error here. And that's what we want to do. So first, I'm just going to create a type for this component. We're calling it props like you're used to in React or, you know, SvelteKit, stuff like that. So we're using that. And all it is just sentinels, which is just a list of sentinel, which again is just some strings inside of it. Now we're going to create this render function. If you're used to like React functional components, this should look pretty familiar. We have a type here. It says it takes in the props and it's just going to return the string. And I guess in React land, this would be like react.fragment or something, you know? And then we'll just have the template inside of here. We're using these, I think it's an interpolated string. Or an absolute string or something like that. But basically this means that whatever is in here, even if there's like one or two of these, it's just going to think it's just a regular string. It's not gonna require us to escape any characters or something. And so we can see it's just a simple table. We got our row, we've got our headers here, and then here's the templating language, which should look very similar if you're in Vue or Liquid or Svelte or anything like that. So basically we're saying for Sentinel and Sentinels, which matches this, we are going to make another row, filling it in with sentinel.id and then .data.name. And then that's it. Then we're going to create our parser with that helper function we had here. Again, making sure it's type safe by saying, hey, it must take in these props with our template. And now we're going to return a function that takes in the props. And this is what's actually going to call our compiled template. You'll note that I am caching this parser right here. And you don't actually need to do that. And the reason is because in the benchmark benchmarks I showed you earlier, the difference was actually like 0.1 milliseconds. So if you don't really care about the 0.1 millisecond, it's fine to not cache. And I probably will move away from caching myself, but just know you can do that if you have like an especially big template or something. Okay, looking at this way, it's very similar to how you might build a React functional component, but this is all done server side, right, in F#. Okay, so next we'll build our main page, which will utilize this component to render its table of Sentinel values. As this is the root page, this is probably where you'd want to do any sort of DB accesses to build up the page data the UI components will render. I still think a lot of the ideas around React, like, hey, all these functions should just be dumb, only deal with UI, is actually pretty good. And so you can bring a lot of that over that you've maybe learned in those other UI frameworks, and it works pretty well. The Sentinel count prop it receives comes directly from the F# giraffe endpoint we'll look at in the next section. So this might be how you would pass down, data coming from the URL or something like that. And this is similar to the server-side rendering style of SvelteKit and Next.js with server-side data loading. And I think if you've used these before, you'll probably have done the thing where, like, if you're trying to access a lot of data, especially data from backends where you need to pass an API key, you're going to want to do a server-side route, which is going to preload everything, and then it's going to pass that big blob of data it has down to the client side as props. And so this is basically, we're doing all this, but we don't need to worry about server-side, client-side, because it's all server-side. And so this actually helps us kind of remove any of that ceremony you have. It's just one way to do it, which I think makes things a lot simpler. So we are using the simple string concatenation to insert the Sentinel table component into our HTML body. I think this is pretty simple, easy to read, and safe-ish, as we know it's doing safe HTML parsing internally. But I would be curious if anyone has suggestions for more type-safe ways to do this. So yeah, kind of earlier I said that we weren't going to be doing like string concatenation, but here we actually are to actually get the body of the function. I think this is still very readable, and we know it's safe because at least here we know that the contract is type safe. And I can't think of a better way to do this with templating, because if we do straight templating, we're going to still miss out on some of the type safety. So let me know if you have ideas. I think this is okay for now. So for raw values, maybe use the template, and for components that we know are type safe, let's just render the components directly. But yeah, curious if y'all have other ideas. Okay, so anyway, we got main page props. So here we're passing in the Sentinel count. You could imagine is coming from the URL or the request. But there's all sorts of other things you might want to pass down here, like an ID or something like that. And this is how you do it. So here we're going to have a similar kind of function that's like render our components, but we're just rendering our main page. And so it's getting the service tree, which is just our dependencies, which we'll use for DBIO. And then it's getting our props, which is here. And so this again is very type safe. Like, we're rendering this component, but even here we're defining in F# types exactly what we need. And so we're narrowing the room for error. All right, so we're wrapping this in an async block so we can do async operations. And we're going to get our sentinels. This is outside the scope, but basically that just looks in the database for any of these sentinels and grabs them out that we want. Then we are going to basically just make sure that this worked okay. If it didn't, we're just going to throw for our example. And then we're going to send a command to say, like, hey, this page was hit, go create another sentinel. And this is how we're getting the, functionality of every time we hit the page, we want more sentinels to show. Okay, and so have all my data accesses up here. So I'm trying to separate, our IO from kind of the functional bits that don't require IO. And so here's our template string again. This is like, your outer HTML stuff that we want. And then here is where we're trying to render our child component. And again, this is all type safe because we're relying on F# here. This is all just F# here inside the interpolated string. Next, we're using our little helper guide to say, like, hey, we want this template, and this template requires these props to load. And then we're just returning the value of that. Yeah, only thing to call out is we are doing some kind of F# to DBIOs. That's outside the scope of this, but if you want to learn more about that, you can check out this blog post and tutorial I have on F# and Entity Framework. All right, so at this point, we should have a decent idea of how we can build component-like renderers with type-safe functions. All that's left to do is hook up our giraffe endpoints to actually render this page. Now, explaining the giraffe web framework and how endpoint routing works is beyond the scope of this article, so we won't go into detail. But if you want to learn more, you can check out this post on building a simple F# web API with Giraffe, or if you just want to look into endpoint routing, you can do that here. So basically what we've got to do to return this HTML via Giraffe is register our endpoints for Giraffe to our renderers. So how do we know that this URL needs to go to like these handlers so that it actually creates that HTML we want? We also have to tell Giraffe that it needs to return our HTML strings as HTML. If you don't do this, it's going to try to return it as like just text, and the browser won't understand it because it won't know what the payload is. So it's just going to render it as like the raw HTML there, which isn't what we want. And the last thing is we need an HTTP handler for our main page. So Giraffe Giraffe has an interesting setup, which is very composable, but like it's very kind of scary at first. And so we need to convert from what Giraffe wants as an HTTP handler to what we expect in our code, which is very just like normal F#. So this seems like a lot, and I'll be honest, it is a bit of a faff to get fully set up with Giraffe routing, but this approach is very flexible when you inevitably need that, and for the most part can be handled simply once you've built a helper function. Or this should be middleware, when you inevitably need middleware. And we'll see like a quick example of this in a bit. So we're going to build the above steps backwards so we can see how everything is defined and flows into the next. And this is one thing I love about F# is it really requires everything to be defined before you call it, so you can see kind of what the dependencies are, and we avoid those circular dependencies. So first we build an HTTP handler for our main page. This is a type registered by Giraffe that takes in the request context and the next function and the call stack, which is very useful for building composable middleware, as I mentioned earlier. So here's the HTTP handler. Here's the dependencies we're getting. You know, that think of like dependency injection is right here. And this is the HTTP handler. So it takes in a func. So it's like the next thing you might want to go to. And it takes in a context, which is the context of the request. This is how you get like data off of it. You don't need to know too much about it, but just like if you think of this as boilerplate you need, that's fine. And then what we're going to do is we're going to just say, hey, call that render main page that we built earlier. We're passing in our dependency injection, and then we're giving it this thing. And so here we're just setting a raw value, but you can imagine that like in the request context here, you might have passed a parameter in the URL. This is where you'd get it, and you'd say like context.count or 10 or something like that. So now that we have that, we're going to tell Giraffe that it needs to return the string we give it as HTML and not a raw string. Again, this is how we tell the browser this is HTML. You need to render it like HTML, not like this is just a blog post that happens to have HTML in it. So we're going to build a helper function because we don't want to have to write this every time, trying to minimize that faff. This helper function is basically a composable middleware that is acting on the request return values, converting the return string into an HTML result. Giraffe understands. So basically, this is why Giraffe is built this way and why it's so composable is I can say, here's render view, give me a handler. So like, you know, our renderer that we wanted earlier, and I'm going to return another HTTP handler. And so what I'm doing is I'm saying, here's this handler, this middleware that we're building has the same type as, you know, the renderer we just made earlier. What we're going to do is we're going to get the result from it. So we're going to say, hey, handler, I'm giving you next in context what you need. And so for our case, the main page would like render here. And then what we can say is we're going to return the HTML string, a result with next context, return that. And so this is the function we're taking from Giraffe, which is going to, I think it sets some headers or something so it knows that what we're returning is actually HTML. But we can kind of just wrap all this complexity in render view, and we can call render view that way. That's how we're getting these composable middleware. Okay, so now that we've got that handled, we just need to register our endpoint so Giraffe knows to send requests from this URL to this hand. Hopefully this will make it clear how all these utilities work together. So we're going to have construct endpoints, and you could imagine that every domain might have its own function like this, taking in its dependencies here, which I call a service tree. And then you can call this at the root of your app to build, you know, everything that that domain needs for endpoints. And what we're passing back is an endpoint list. And so this is saying, hey, for get requests, if the route is /sentinels, we want you to render a view. This is going to be that function we just said. So this thing is going to create strings, and I need you to return it, and as a middleware, return it as HTML string. And then we're going to call our actual main page handler here with its dependencies. So there you have it, a server-side rendered HTML with F# and Giraffe using simple F# functions, giving us all the ergonomics and type safety of the F# language. I'll be exploring this more on my journey to experiment with reactive server-side UI using tech like HTMX. So let me know if you have any questions, and I'll try to answer them next time. If you like this post, you might also like build a simple F# web API with Giraffe to learn more about F# and Giraffe together. You might also like learning more about F# and Scribon and how fast it is, especially if you're trying to use this maybe for some production apps. Performance might be critical for you. And then if you're just interested in kind of how you build full stack apps with F# and how I've done it previously with SvelteKit, you can check out this post as well. That's it for this video. Thanks for watching, and I'll see you in the next.